Okay, so let's do a quick section on graphs of trig functions. Suggested exercises are 1, 3, 5, 7, and 13. The main concepts are going to be periodic function, amplitude, and phase. I'm going to ask for you to work through examples 1, 2, 4, and 5. Okay, so a function is called periodic if there exists a real number p, so that for all x in the domain, f of x plus p is equal to f of x. We call p, periodic, p the period of f. Now, if we have a periodic function, what we're thinking about is, the function does something, and then it does it again, and then it does it again, and then it does it again. There's a third little bump here, just pretend. And the idea is the distance from here to here is p. So that I can find f of any x by just looking at, either p units further or p units behind, and multiples of p as well. Now, I'm not going to be a stickler about, maybe you found 2p, but whatever, it's still periodic. Now, in a periodic function, the amplitude is half the difference between the max and min values of a periodic function. Because there we go. Also, horizontal shift can be called a phase shift. And this is, so if I shift this function, this periodic function, if I shift it by p, it's going to look exactly the same. So when I call the horizontal shift a phase shift, what I'm doing is I'm saying it's a horizontal shift, and if you shift by a multiple of p, then you're not going to be able to see the shift. Moreover, if I shift by p plus something, it's basically like I'm only shifting by that something. So the main theorem, and this is going to be for sine and cosine, is that the functions a cosine omega x plus phi plus b and a sine omega x plus phi plus b have amplitude, absolute value of a, period 2 pi over omega, phase shift negative phi over omega, and vertical shift b. And all of this is going to be just the same as we have done before for transformations of functions. The difference is that we're giving some names to some of these quantities. So you notice we have the absolute value of the amplitude because there could be a vertical flip, right? If I had flipped this thing upside down, it's still got the same amplitude. And for sine and cosine, they're symmetric about the x-axis, or they go just as far above as they go below the x-axis, so that's how we get this amplitude. So let's do a quick example. Let's sketch. Let's do -2 sine 3x plus 1. So I'm just going to sketch, I guess, 1, 2, 3, 4. I'll just sketch 4 things here. So solution. First, we'll just sketch y equals sine x. And that's just, it goes up, down, up, between plus and minus 1, and the period is 2 pi. Now let's sketch y equals -2 sine x. So it'll be similar, but now instead of going up, down, up, we're going between plus and minus 2, and we're going to go down, up, down, between 0 and 2 pi. Now let's do y equals -2 sine 3x. What this is going to do is it's going to reduce the period. So if it took us 2 pi hours to watch a movie and we watched it at triple the speed, it's going to take us 2 pi over 3 hours to watch the movie. So this is 2 pi over 3 now. And our final answer is going to be y equals -2 sine 3x plus 1. So it'll be the same sort of picture, except now instead of going between plus and minus 2 like this one, we're going to go up to 3 and down to -1 because this has been shifted up by 1. So it's got this sort of new middle line up here at +1. We're going down to -1, then up to +3, and then we're ending at 1 there. Let's get rid of this mistake bit. And the period remains the same, 2 pi over 3. So that's going to be our final answer. I hope that helps.